Hello again. So this is part 4 on sampling within the week 2's lecture on quantitative methodology. So in this section, we're going to look at the different types of sampling and that how it can help you to do better research. So when you are doing quantitative research, you're always interested in how your research can be representative, how it can be generalizable to the broader population of your interest in the research. So what is sampling, right? Remember when you go to see a doctor and the doctor or the nurse take your blood, right? You can know, the doctors can know about your whole body's problem by just taking a small amount of blood from your body. So sampling is not much different from a doctor taking a small sample or small piece of your blood to study it, to generalize it to your whole body, right? So in sampling, you need to know what is the problem that you're studying, and you want to know whether the theory that you're trying to study will apply to how broad is the population. And that also help you to know how much data you need to collect, how much money you need, how much manpower you need to have in order to do a good research, right? So in sampling, you want to do sampling for a variety of reasons, right? Imagine with the blood taking, right? So it's very impractical to take the whole blood because your patient will die if you take the entire blood, right? And taking just a piece of blood is cheaper, and it can be very informative if you take it in the right way, that it can represent the entire body. In the same way, people who are who wants to be a father, for example, right? So they went to check to a specialist doctor, and the doctor will check their sperm. And this is what the sperm look like, the second one. What the sperms look like under the microscope. They look like a little thing that have head and tail, they can move around, right? So that will be a sample of the sperm. And there's also a very good reason why sampling is needed, because after you do the sampling, you know the characteristics of the phenomena, let's say the characteristics of the sperm. And if this person, let's say, do not have the natural ability to conceive, to have a baby, then they could do an IVF, in vitro fertility, or in vitro fertilization, in which the wife from the eggs from the wife and the sperm from the husband are fused together. So in the lab, right? So the tube, and there's this bubble with a red thing inside, that is the egg. So the little tube there carries the sperm from another tube, which is mixed together with this red bubble thing. So the sperm will be inside, and it will lead to the eggs being fertilized and split into two, and keep on building in terms of this chromosome and become a baby. So there's a lot of reasons why you want to do a sampling, because it can help you understand a phenomena better, right? So in sampling, you have a subject or participant or respondents that you are interested in. That is a single person, right? It can be an employee, a student, a patient, a citizen. And from there, you hope to have multiple of them. It could be hundreds of them, or thousands of these, and they form a sample. A sample is a subset of this population that you are trying to study. But where do you get this sample from? Let's say you are doing a study on the citizens' happiness with the public service, right? Or the, let's say, whatever kind of public hospital, let's say public hospital, right? But where do you get the sampling frame from, right? So the sampling frame is a very complete set of people that is already available, right? That you can send out so you can get the samples. So this is what I call sampling frame. Frame is a kind of a database, or kind of a collection of information about various type of people or participants there, right? Let's say you want to study about how successful are CTU students in getting jobs after graduation, right? So your interest is the students. The sample could be the people who respond to your survey. right? Your sampling frame could be the email directory of CTU students. Let's say you're focusing on students in College of Business or College of Liberal Arts and Social Sciences, right? So you can send to each of these or both of them, right? Up to you, depending on where you want to generalize. If you want to generalize what is the successful rate of social science students in CTU, then you send this to the email directory of CTU class students, College of Liberal Arts and Social Sciences, right? And that email directory is a sampling frame, right? But what is your population? Your population could be the entire student of interest with CTU. So you want to know what is a CTU's success in getting jobs. You can look at it in terms of the class or the CB students in terms of their ability to get a job. That's sampling frame. You send out the survey to get a sample and you have the participant. So basically in samples, first of all, you have 1, 2, 3, 4, 5, 6, 7, and 9, 10, 11. You will hopefully to be randomly getting different people to respond to your survey or your request for experiment, and they will take part. And then the responses that they give you in the survey or in the experiment is something that you will use to come up with a conclusion that you will generalize to the population. The population is up to you. You can population as the entire students in CTU, the entire all university students and graduates in the 8 universities in Hong Kong, or all students in the world, or all students in a particular area, all students in business school or all students in social science. So it's up to you how you define it. So that's up to the researcher. Now, when you talk about sampling, you want to have a representative samples, right? So a representative sample is when the sample is similar to the population that you are drawing from, that you are studying. If your sample is representative, it's easier to achieve generalizable results. Generalizable means you only, let's say the whole population is 30,000 people. You only study 300 people. You're hoping that these 300 people to be very representative in terms of their characteristics from the 30,000, right? So if these 300 people are representative of this 30,000, then of course, whatever you find from these 300 people who you are studying in a survey or experiment, then they will be, their findings can be generalizable to these 30,000 people. So that is exactly what you are interested in. So when you want to have representativeness, you define the population, identify sampling frame, select a sampling procedure, determine how much is the sample size, and you select the sample units, and you collect the data. So there are different types of sampling types. Basically, they fall into 2 broad categories, and each one of them has multiple types. In statistical analysis and statistics and any kind of quantitative methodology, you are interested in probability sampling. Remember, I mentioned in part 1 of this week's lecture on statistical reasoning, I talk about probability. So probability thinking is one of the main ways of thinking about statistics. So probability means the probability of a subject, a person, a participant, a respondent to be selected as samples. So first of all, simple random sampling is very easy. Let's say you want to do a random sampling of how successful is CTU students to get a good job, right? And you stand next to this entrance gate of CTU and you look at people who are passing by the campus every day, you stop them randomly. That is a random sample, simple random sampling, right? A non-probability sampling is when you want to find samples, but you don't use it. So this the chance of everyone being selected is not important. So the random chance of everyone to be selected is not important. So, but you are more concerned about the insights from the people that you can study. For example, convenience sample. Convenience sample is, okay, you interview. The question is how successful are CTU students in getting jobs? You go and interview your friend, or you go and interview the senior who are 2 years more senior than you in your education in the school, because you happen to know them. That's called convenience sample. So this type is not very representative, right? Because it can be biased because this person is connected to you, right? So in terms of probability sampling, there are different types. Let's go through one of them: simple random, systematic sampling, stratified random sampling, cluster sampling, area sampling, and other types. So for example, in terms of probability some definitions for the probability-based sampling. What is called homogeneous? What is called heterogeneous? Right? When you say your sample is homogeneous, then in that group they should have a lot of similarity. For example, you're studying year 2 law student or 20-year-old Hong Kong Chinese students majoring in law, then the people in this group should be very homogeneous. And that could be very different from other groups. Let's say the group called international students who are studying in this university, right? So the group of internationals will have very different characteristics. They are different from the law students. So law students is very specified groups with a specific characteristics. Heterogeneous means they have differences. So what is this random sampling? Random sampling means every member or every subject or participant or respondent has an equal chance of being selected as part of the sample. For example, you want to do what is the IQ of Hong Kong residents? You want to use a random sample. So you must ensure that everyone out of 7 million people in Hong Kong have a chance to be selected. So you cannot just go to your neighbor and knock their door and say, hey, I want to measure your IQ. Then your approach to getting this sample is not random enough, right? So you need to find a very good way to do it. A simple random sample, for example, each one of us has ID card, right? Let's say ID card. ID card has a number. You can use the last 3 or 4 digits, up to you, right? If depending on the size of the samples that you're looking at, and like you can use this number to generate a random output. Actually, you can ask SPSS or R to give you some random numbers out of a set of numbers. Let's say you have a list of people's ID card, let's say from 001 to 10,000, right? And you can ask your software to give me a random numbers of 200 people from these 10,000 people. So your software, like SPSS or R, can give you this random number. And from this number, then you contact them either by phone or by email if you have access to their database, right? So this is very random. You can also stand outside of the shopping mall and randomly people who pass by, but you must make sure that you don't only stand on a particular day or particular hour, because only a particular type of people will pass by a shopping mall on a particular day, on a particular time. For example, you will not see me near the shopping mall on the weekdays because I'm at work, I'm busy at work, but I'm more likely to be in the malls in the weekend, right? So if you want to study random people about something that you want to study, whether it's about citizen satisfaction, about public service, about people's satisfaction with the shopping mall, then you need to find people across different time zones on different days so that your result is not skewed or biased to a particular time or particular day. Systematic sampling. Systematic sampling means everyone, you use a very systematic way so that everyone can be selected using a certain steps. For example, you have 11 people in your population, you only pick every third person, right? That's it. The second person, the fifth person, the eighth person, etc., etc. And then in systematic sampling, for example, you want to study about people in housing estates, and people's housing estate has numbers, right? You can go to every fourth flat number 1, number 4, number 8, number 12, or you can also look at other ways to find samples, every 5, every second. So, but it can also have systematic bias. For example, some people do not want to live in certain flat that have number 4 or number 13. But this is what it means to be systematic. And another one is called stratified random sampling. So in stratified random sampling, you divide your sample into strata, into different subgroups that are natural. For example, if you're studying about people's income, what drives people's income, you can divide the strata in terms of, say, male and female. If you want to study about students' academic performance, you can divide them into, let's say, freshmen sophomore, junior, senior into your subsample. And then you can select from each type. For example, from male, you select a number of them, from female, but in the different type of stratified random sampling, for example, this freshman, sophomore, junior, senior, you will select randomly from each group. Right? Cluster sampling. In cluster sampling, you want to ensure that your clusters are heterogeneous groups of people in each group. Remember, I just talked about stratified sampling. In stratified sampling, it looks like the one on the left, right? The picture, the one on the left, in which you have specific groups, and you are only picking people in certain groups that are similar to each other. So the black are black, the blue are blue, the red, the brown, and the green. But in cluster sampling, within each group, you want to have some variation within each group. For example, you want to study buildings within a certain housing estates. So housing estates have 10 buildings. So you can study this whole housing estates. So you want to study different clusters, A, B, C, D, E, F, and different clusters and different stratified clusters. So it's up to you to choose what type to suit your question. The next one is called area sampling. Area sampling is when you know specifically the areas that you want to study. For example, this is a study on what happens to a particular groups of people or families in a specific township or village in China, right? So they zoom in from the one in the middle in yellow, and they zoom in and say, we want to study these people who live in this different area. So the red dots are the people or the families who have been sampled. So area sampling is you select based on location. For example, you want to study about what is the holiday preference of the rich people who live in mid-levels. Also, you don't assume that they're all rich, but actually many of them are very rich in mid-levels in Hong Kong. So this is based on certain area. And then you can identify where they live, and you spread your questionnaire there, and you can capture the study. So when can you use, and the other type is called non-probability sample, but when can you use? When generalizability is not important to you, right? When it's not important, being generalizable, then you use convenience, judgment, or even quota sampling. So what is convenience sampling? Convenience sampling is when you conveniently get people to participate in your research. This is used a lot in qualitative research. So people want to study their friends, they study their colleagues, their family members, or students who pass by the campus, people who pass by a mall, they just ask them direct. So because it's very convenient, it sounds like random sampling, but it's actually very convenient, and it can have a certain biases. But your concern is not about representativeness or generalizability, but your concern in this type of sampling is you want to get some insights from the people that you interview. Again, I mentioned non-probabilistic sample is good for qualitative. The other type of non-probabilistic sample is called judgment or purposive sampling. Purposive sampling is very popular. So you want to find people or subject who are best able to provide the information that you require. For example, you want to know about what is the economic prediction about the economy next year. You can go and interview a bunch of senior financial managers in the central area. Or you want to know about what is the effect of corruption, and do companies need to participate in it? You can ask a number of CEOs and study how do they feel about corruption, what do they think about corruption, and the implications of corruption. In the table that I show here is one example of a study of how the nurses are supporting the elderly. So in order to study the elderly, they're studying the nurses who take care of the elderly. They have 21 respondents, right? So basically they are looking at the nurses with different number of people who work in the rural or urban areas and work for different types of healthcare organizations. And basically they can classify into male, female, different age, different sort of years of working as community nurse and where they work, rural or urban and others. So these are the sample that they can identify. And this does not need to be purely random. It can be from some organizations or some nurses that they happen to know, or they have a certain characteristics. And there's another type of purposive sampling that we don't talk much about. For example, you want to talk about nurses who perform very well in their job versus nurses who don't perform very well in their job. You can have two groups there. It's a naturally occurring groups. And you can study their characteristics and what makes them successful, what they're performing very well. So this is also another type of purposive sampling. So this is another type of how people do a purposive sampling when they recruit people on Twitter. So you can have a look at this example. So they make a recruitment, they set the recruitment, and they conduct a survey, they send the URL and things like that. So there are many new ways right now to do purposive sampling. The next one is called quota sampling. So in quota sampling, you set a specific number that is proportional to the size of each strata that you are studying. For example, in College of Liberal Arts and Social Sciences in CDU, let's say you have 40% male and 6% female for all the students in CDU class, right? And then when you want to do a survey, you will select a proportion of your sample should have 40% men and 6%. If you have 1,000 people, so you have 400 men and 600 women. Or for example, this is another example of a research on how people do a sampling in qualitative research. So they want to study about 30 couples, men and women, who are having some challenges of having an elderly to live together, having an elderly to move to live in a care home, right? So the target is you want to interview 30 people, but this is how they set the quota. 10 whose father have gone into the care, elderly care, and 10 couples who have their mother have gone to elderly care, another 10 who come from low socioeconomic status, 15 who come from outside of a particular area, and 5 unmarried, and 5 who live 100 miles away from their parent. So they need to set aside different criteria, and then they will go and find different people who can fit in so they can have a total of, let's say, 30 couples. Generalizability is not important for non-probabilistic sample, but it's very important for probability sample. Sample size. Now, the rule of thumb is typically the larger your sample size is, the better, because the larger sample size that you have, the higher confidence that you have with the result. Okay? So with the higher sample size, yeah, your confidence that your result is not due to random chance, but it is because you have a true value that you can closer in your estimation of this true value, then you are becoming more confident. So that's why in quantitative research, you always want to have a larger sample size. You want 1,000 respondents than 50 respondents. You want to have 10,000 respondents rather than 100 respondents. But it also depends on other considerations such as budget and time, resources, access to the people that you want to study or the organizations that you want to study and things like that. Of course, the larger the variance of the groups, the lower your confidence. But you need to have some variance, of course. If there is no variation among the 1,000 people that you are studying the survey, then your survey will not work. So why sample size matters? So you want to do a small survey, and you want to know about whether gender has anything to do with people's income. You have only 3 samples. One male have this salary of 8,450, another male 8,800, another male 8,900. If you calculate the average salary, the male is, the first male and the other male, you add it up, divided by 2, it gives you $8,675. And the female is the same, 8,800. So it seems here that female has a higher salary than male. But does it prove that women make more income than men? Then the problem is your sample size is very small, only 3 people, right? So if you calculate your T is not significant, it's not confident enough. Why? Because the sample size is too small. So how do you deal with that? Then you need to have larger sample size. So how big is the sample size? There's no hard formula, but people always use between 30 to 500 or even bigger if possible. If you have subgroups that you want to compare, then you should have at least 30 in each subgroups. And another good rule of thumb is to have 10 times the number of the variables that you're studying. So for example, if your variables have 5 variables, let's say one dependent variable and 4 independent variable. In total, you have 5 variables, right? How many samples do you have? Do you need to have? You need to have at least 50 people. So 10 times 5, right? But of course, you want to have more if you can. So people who are doing experiment, they may use between 20 to 25 or even 30 per each group that they're comparing. For example, you are conducting an experiment on 2 groups. One is the control, one is the treatment group, right? You give a medicine to this group and this group. So you shouldn't have only 2 people and 2 people in each group. Then your result will be very biased, could be wrong. You want to have at least 25 who have taken this medicine and this take another medicine, and you compare the result to see who gets cured. So this leads me to the final slide, the conclusion. So the things that we discussed in this week's lecture, when we talk about quantitative methodology, quantitative data, and how to measure them, how to sample them, is a lot about positivism or deductive or variance approach, right? The important part is you need to use the right question to use in quantitative research, right? And statistical reasoning is very important, from normal distribution, probability, correlation, prediction, causation, error, p-value, f(x)(s) power. These are all very important concepts in statistical reasoning. And p-value is very important because it helps you to reject or accept a hypothesis, right? And of course, you want to have in social science, you want p lower than 0.05 or 5%, which means that the chance of making mistakes or error is only 5%, and 95% you are more confident that the result is true, right? And of course, the lower the p-value is always better. Effect size is important if you want to know whether your intervention works or not, if you're doing experimental type. In survey type, you don't quite use a lot of effect size. Power analysis is also very important because it gives you confidence about the findings, and power analysis will help you determine how big is your sample size needs to be. Causality is king. And causality is the most important. Correlation is about association, but it's not telling you about causation or causality. So you can make a measurement by understanding the object, the properties of it, and how you create indicators or measures to measure that object. And you have 4 basic types of measurement scales: nominal, ordinal, interval, metric. We'll talk about all this. And we'll also talk a little bit about reliability and different types of validity, from content, phase, construct, convergence, and discontinuity. Hopefully that's useful. And lastly, if there are well-validated and highly reliable constructs or scales or measurement scale that people have developed, then you don't need to develop any from scratch. Use other people's already validated scales. That's it. Bye.